Okay, here's a question on formal charge. From Alex, the student proposes the following Lewis structure for carbon dioxide, and here's the structure. It's maybe not one that I would draw or you would draw, but it's one that a student drew, and so it's asking to assign formal charges to the left oxygen, the carbon in the middle, and the right oxygen. So let's actually go through and do this. Here I drew what the student drew right here, and so let's just kind of review real quick formal charge. So formal charge is going to be calculated by finding the number of valence electrons for each atom, and then from that we're going to subtract the number of lone pair electrons, and then from that we're also going to subtract 1/2 of the bonding electrons around that atom. Okay, so that's one way. Another way, just kind of look at it just very simplistically, is to take the number of valence electrons minus the number of dots that you see, which are the lone pairs, minus the number of lines that you see. And so for here we have oxygen on the left, we have carbon, we have oxygen on the right. Okay, and so let's just go through and calculate the formal charge for each of those. Okay, and so I am going to do it using the valence electron dots lines right here. And so let's go ahead and do that. Oxygen has 6 valence electrons, carbon has 4 valence electrons. The number of dots around that left oxygen are 2, 4, 6. There are 6 dots. The number of lines is 1 right there. So the middle carbon, the number of dots, there aren't any dots, and the number of lines are 1, 2, 3, 4. Okay, and for that right oxygen, the number of dots is 2, the number of the lines is 3. And so let's do the math there. 6 minus 6 minus 1 is a -1, which is the formal charge on that oxygen. 4 minus 0 minus 4 is 0. And then 6 minus 2 minus 3 is 1. Now when I add up those electrons, or the formal charges, then this needs, regardless of whether the structure is correct or not, then this plus this plus this needs to equal the charge on the overall molecule, which in this case is 0. So -1 plus 0 plus 1 is 0. Alright, so that is the formal charge for for the atoms in carbon dioxide. And so let's go back to Alex and answer the question. So the formal charge on the left was a -1. The formal charge on the carbon was 0. The formal charge on the right oxygen was a +1. And so let's go ahead and check this, make sure that we're correct. Okay, and we are correct, and it gets a little fussy about the conventions used. I want to go back there and just discuss something real quick. Now, if you and I were probably doing carbon dioxide, we would have drawn it just a little bit differently. We would have taken that C, we would have probably taken those 2 oxygens on either side like that. 1, 2, 3, 4, 1, 2, 3, 4. The total valence electrons that need to be on carbon dioxide are 4 from the carbon and 6 from each of the oxygens, which is 12. So there should be a total number of 16. For this carbon dioxide that we drew was 2, 4, 6, 8, 10, 12, 14, 16. This is a valid Lewis dot structure. Yeah, but so was this a valid Lewis dot structure. And so the question is the student had, well, geez, which one do I do? And that's where we will use formal charge to help us know which one of these structures is going to be correct. So let you and I just quickly calculate the formal charges for each of the atoms in this particular Lewis dot structure. So we have the oxygen on the right, we have the carbon in the middle, we have the oxygen on the right. Alright, so let's just go ahead and do our little table like we did before, where we have the number of valence electrons, we have the dots, we have the lines. So for the oxygen on the left, the number of dots are 2, 4. There are 4 dots. Let's go ahead and kick in our valence electrons here. Number of lines is 2. Okay, so for the carbon, the number of valence electrons is 4. The number of dots is 0. The number of lines is 4. And so oxygen, the number of dots is 4. Number of lines is 2. So when we calculate the formal charges used for this particular structure, 6 minus 4 minus 2 is 0. 4 minus 4 is 0. 6 minus 4 minus 2 is 0. So we could use our formal charge to understand a little bit that this energetically is going to be much more favorable than this right here, because it has the lower total of formal charges on each of the atoms right here. So even though Alex just asked us to look at this guy, I want you to understand that we can use formal charge to help us understand which Lewis dot structure might be preferred.